All right, so let's say we have the problem on the board. We are asked to investigate or find the stationary points and nature for the given function f of x equal to this. Okay, so there is no really big deal in looking for stationary points. It simply means to obtain stationary points, simply differentiate the function partially with respect to x and equate it to 0. Also differentiate the function partially with respect to y, also equate that to 0. Okay, so we have the given function now. We first of all find partial f partial x. Okay, so partial derivative of f with respect to x, as always, you keep y constant and differentiate only x. So we simply keep y constant. We have 3, y hold it constant and differentiate x squared. If you differentiate x squared, you simply have use the power 2 to multiply x and then subtract 1 from the power. It becomes to the power of 1. All right, plus now I have y cube, and since y cube does not contain a variable in x, it simply means that y cube is a constant, and as such I can't differentiate y cube with respect to x, so this derivative becomes 0. Okay, minus, I will differentiate now 3x squared. If I differentiate x squared, I simply have 2 times 3 gives me 6x. Okay, so this becomes the partial derivative of this function with respect to x. Of course, this is y squared and no terms contain x here, so which means I can't differentiate this function with respect to x. It simply gives me 0. So I have this. Next is to obtain partial f all over partial y, differentiate the function with respect to y, and if I do that, in this case now, I will hold 3x squared as a constant and differentiate only y. So I'll simply keep 3x squared. If I differentiate y, I will simply have 1. Okay, plus I have here y cube. Differentiating y cube, I will simply have 3y, remove 1 from the power, it becomes 3y squared. Same thing here, I have 3x squared here. The derivative of 3x here with respect to y becomes 0 because x squared here does not contain any variable in y. So this derivative becomes 0. Okay, minus differentiating minus 6y squared, I will simply have 12y. And of course, if I differentiate 2 with respect to y, that's simply 0. 2 is a constant. All right, so our stationary points, also called the critical point, our stationary point, also called critical point, these partial derivatives are all equal to 0. So I will simply equate this to 0. I will have 3y into 2x. All right, so evaluating this now, this becomes 6xy, okay, plus minus 6x, and this is equal to 0. Okay, that's equal to 0. Next, equate partial f partial y into 0. It becomes 3x squared here, okay, plus 3y squared minus 12y equal to 0. So I simply have two equations, equation 1 and equation 2. So I will solve this simultaneously now. The very first equation, I notice that 6x is common between the two. So I can actually factor out 6x. So from equation 1, from 1, I will simply have 6x into, I'll have a y minus 1, and that's equal to 0. So for two multiples to be equal to 0 from quadratic equation, it simply means that either 6x is equal to 0, or I will have y minus 1 to be equal to 0. So let's consider the second option now. From y minus 1 equal to 0, I can simply obtain a value for y directly. This simply means that y itself is equal to, send minus 1 over here, it becomes positive. So y equals 1. Now, if I know the value of y, I can now substitute this value into equation 2 and obtain values for x. So substitute y into equation 2. If I do that, I will simply have 3x squared plus 3. In place of y squared, y is equal to 1, so it becomes y all squared minus 12, and that's equal to 0. Okay, so this gives me 3x squared plus 3 minus 12 equals 0. So 3x squared, 3 minus 12 gives me minus 9 equal to 0. So I can send minus 9 over to this side of the equation. I simply have 3x squared equals 9. Of course, negative sign cross and equal sign becomes positive. And to make x squared subject, divide all through by 3. Divide all through by 3. This implies now that x squared is actually equal to 9 all over 3 remains 3. So I will find now the value of x by taking the square root of 3. So I have plus or minus root 3. So which means that x is equal to plus 1.73 or x equals minus 1.73. So the values of x exist when y is equal to 1, we actually have two values of x. So this actually means that, okay, when y equal 1, we have x to be equal to 1.73. Also, when y is equal to 1, we also have x to be equal to minus 1.73. So which means the stationary points are, hence, the stationary points are, okay, are simply when, okay, when x is 1.73, we have y to be 1. And also, when x is minus 1.73, we also have y to be 1. So these are the stationary points in the given function. All right, guys. So that's how you find stationary points of a given function. In the next video, I will see you with more problems on application of partial derivatives. In the meantime, if you're new to the channel, please don't forget to, of course, tap the subscribe button to keep getting much content and updates when these contents keep dropping. I will see you in the next video. Thanks and cheers.